Today we're going to discuss inverse variation. So your essential question is, how can I tell what kind of variation is shown by looking at an equation? So first we're going to learn what the equation for inverse variation is. And the equation is y equals a divided by x. Now in this equation, a cannot equal 0 because if you have 0 divided by a number, it equals 0. So we can't have a be equal to 0 because then we would have y equals 0, which is not the same. So as long as a does not equal 0, this would be the equation for inverse variation. Now we've also learned about different types of variation, such as direct variation, and we'll talk about those here in a minute too. So A is called the constant of variation. So that's something that is the same every single time. It never changes. That's why it's called the constant. So whenever you hear the phrase y varies inversely with x, then you know you're going to be using the equation for inverse variation. So it says, tell whether x and y show direct variation, inverse variation, or neither. Now remember, we did direct variation at the beginning of first semester. The equation for direct variation is y equals a times x. So these are directly multiplied together, and then since this is division, this would show inverse variation. So if it's in this formula, it's direct. If it's in this one, it is an inverse variation. So if we look at this example, x times y equals 7. Well, in both of these equations for inverse variation and direct variation, y is by itself. So we have to get y by itself before we can tell. So what we're going to do is we're going to divide by x to get y by itself. So we get y equals 7 divided by x. And so in this case, since we have a number divided by x, this would be inverse variation. So it's pretty easy to tell. Okay, y equals x plus 3. The numbers x and 3 are not multiplied together, and they're not divided. So this one would be neither. And then we have y divided by 4 equals x. Well, again, we have to make sure y is by itself before we can tell. So to cancel out the dividing by 4, I would multiply both sides by 4. So then I would get y equals 4x, which would be a number times x, which would show direct variation. So to tell what type of variation it has, you're going to look at the equation. You're going to see if the numbers are multiplied together or divided by each other. Okay, now we're going to write an inverse variation equation. So it says that variables x and y vary inversely. So we know just from that phrase right there that we're going to be using the equation for direct variation, which is, inverse variation, which is y equals a divided by x. We know that y equals 7 and x equals 4, so we can use that and plug these into this equation. Okay, and it says write an equation that relates x and y. Whenever it says this, it means use x and y in your equation. A lot of people think that just means plug in all the numbers that they gave you and just leave it like that. Well, that's not really using x and y. Okay, and then we'll find y when x equals -2. So we've got a lot of things going on. We know first we're going to use the equation for direct variation or inverse variation. We're going to plug in the values for x and y into the equation. We know y equals 7 and x equals 4. So we have 7 equals a divided by 4. We do not know what a is, so that probably means that we're going to solve for a. So to get a by itself, I would have to multiply both sides by 4. So then I would get A equals 7 times 4, which is 28. Now that's my constant, okay? But my directions said write an equation relating x and y. So now we're going to write the new equation by plugging in what we got for A. So we're going to use y equals A over x, but instead of A, we're going to have 28. And that's going to be the answer. Okay? But then if you go back up, it said then find y when x equals negative 2. So now using the equation that we just wrote, we're going to plug in x equals negative 2 and find the value of y. So we get y equals 28 divided by negative 2. So we get y equals negative 14. So for all of these problems on your homework, you will have two answers. You will have an equation using x and y, and you will have a value for y, most likely. Okay. Another type of variation that we have not seen yet is called joint variation. Joint variation is a type of direct variation. So you'll notice that it says that it varies directly, so that means that all the numbers are going to be multiplied together. So that's why it says the product of two or more other quantities. So joint variation is like direct variation with more than two variables, basically. So, for example, if it said z varies jointly with x and y, then you always have to have an a in your equation because you always need a constant of variation. Something that stays the same all throughout your equations. So no matter what, in all of these equations, you're always going to have an a value. So if z varies jointly with x and y, then z is equal to a times x times y. And if p varies jointly with q, r, and s, then p is going to be equal to a times q times r times s. So those are just ways that you can write joint variation equations. So now we're going to do a problem that has that. So it says the variable z varies jointly with x and y. So that tells you right there that you should write an equation. And remember, we always have to have an a value. So this would be our joint variation equation. Then they tell you z equals negative 75 when x equals 3 and y equals negative 5. So we're going to plug in all those values and find out what our constant is. Okay, so first we wrote a general joint variation equation. We're going to plug in all the values that they've given us. So we know z equals negative 75. We don't know what a is. We know that x equals 3. And we know that y equals negative 5. So if we work this out, we get negative 75 equals 3 times negative 5 would be negative 15a. So then if we divide by negative 15, we can get a by itself. So we get a equals positive 5. So now it says write an equation that relates x, y, and z. So that means I have to have an x, a y, and a z in my equation. So I'm just going to take that first equation that I wrote. So I'm going to have z equals, well now I know what a is. A was 5, and then I had x and y. So this is my equation that relates z, x, and y. So we're going to have all those actually in the equation. Now we're going to plug in, it says calculate z when x equals 2 and y equals 6. So we're going to plug those into our equation. So we have 5, we have 2 for x, and we have 6 for y. So if we work these out, we have 5 times 2, which is 10, 10 times 6, which is 60. So z equals 60, and that would be our answer. So here is our equation that relates z, x, and y, and here is our answer for z when we know x equals 2 and y equals 6. All right. We can also compare different types of variation, so you can kind of mix them together. So you'll notice that we have directly and inversely here in the same sentence. So it says z varies directly with y, and inversely with x. So if I know that it varies directly with y, then that implies that it's going to be multiplied, and inversely implies that it's going to be divided. So this means that z is going to equal, and remember I always have to have an a in my equation, so I'm going to have a times y, because that's how they would be directly related, and then inversely means I'm going to divide by x, so this would be the answer. Okay, b varies jointly with t and r, so we have 2. And remember, joint is a type of direct, so this would mean I'm going to multiply. And inversely means I'm going to divide. So I have x equals, and I always have an a in my equation because I have to have a constant. And then it varies jointly with t and r, so I'm going to have those multiplied together. And inversely with s, so I'm going to be dividing by s. So this would be my answer. I have one last type of example that I want to show you using a table. So it says, determine whether x and y show direct variation, inverse variation, or neither. So remember, direct variation is y equals a times x, and inverse variation is y equals a divided by x. Now, if I see this equation, I have an x and I have a y, but I do not know what a equals. So if I was trying to solve for a in this equation, I would divide both sides by x, right? So a is equal to y divided by x for direct variation. So it's kind of flip-flopped. If I wanted to solve for a in this one, I would multiply by x. So I would get that a equals x times y. So it's opposite when you're solving for a. These ones are multiplied together and these ones are divided by each other. So if I look at this, if I take 132 divided by 12, I get 11. And then if I take 198 divided by 18, I also get 11. And if I take 253 divided by 23, I also get 11. And so you kind of get the picture here. There is a constant, sorry, this is kind of messed up. The constant of variation is 11. Now, I got that by dividing the numbers, so this is actually a direct variation equation. If I tried this and I did not get the same number every time, then it would not be constant, so that would not be direct variation, and then I'd have to try inverse, so I'd have to try multiplying 12 times 132 and seeing if I get the same answer every time. And if I didn't, then the answer would be neither. But in this case, every time I divided y by x, I got the same number. So it shows direct variation. Make sure to go back and read the essential question and write your summary.